I want to show how to use the flame graphing tool, and especially for Rust, there is Cargo Flamegraph, and it's extremely useful if you want to optimize code, because often optimization is just figuring out what is slow and then not doing the slow part or doing the slow part faster. So I'll show the program real quick. It's a tool to visualize binary files. This test file is pretty small. What you can see, we have some colorful blocks here, and I can click different visualizations, and they change the way the file looks. And here we have entropy slow. It says slow, and it is really slow. And the rest is also not as fast as it could be, but I want to focus on that entropy. So let me show real quick. This is the tool, SharkDP Binocle, it's called, and you can have different files and see this is Doom. You see even the little pictures here. Or for example, this is the MS Teams memory dump, and you see the emojis as part of the binary. So the tool I'm going to use is Cargo Flamegraph, which you can install using Cargo install Flamegraph. And I'll show how it works like this. On macOS, you need sudo for sampling, because macOS wants sudo rights to be able to do stack frame sampling, and works by just pausing the program very briefly, writing down what the stack frame looks like, and then continuing. And then we're just going to run it for some time. It's being compiled right now. This is compiled in release mode, and I enabled debug info, so we will have prettier output. Let's set the entropy and have it run for a bit. We can maybe change the size, do some actions, yeah, just to make sure there's some compute being done, and I'll close it. Now it wrote a file flamegraph.svg. So let's open that. And we can see that we spent 100% of our time, 16,000 samples in the all function, most of them in the main. And this is, so here we have one stack, lots of stack frames, 16,000 of those, of which 82% was in the binocle draw function time spent. And a lot of it in the entropy color at index. If I zoom in, we can see that preset spline gets called quite often, and inside the preset spline, so there's a parser, parse function, spline gradient, and so on and so on. Okay. So if you can just get rid of this preset spline function, we would have already achieved quite a lot. So the preset style should be right here, this color grade function, because this is just a macro called preset. What does the macro do? It calls preset spline with the chosen colors. So let's get rid of that. I've initially made it static, but then I got feedback on my pull request to, just do it as it was already done elsewhere and discretize it, calculated the color values once, discretize them, and then print them later. We use entropy as the key. Entropy is between 0 and 1. And there's something called byte color here in the color gradient. So we have an array of 256 byte color at discretized entropy. Now let's do it again, run it again. Elements with colors in them. So let me jump here real quick. Let's add this in here into our entropy structs, and then we need to provide byte color. Let's copy that. $256 values initialized to 0, and then we iterate through them for each color we look at the gradient and compute that. What's the gradient here? Well, the gradient is this function. So we store it like that. And then instead of doing this lookup, here we just need to convert the entropy, the floating point entropy value, into a discretized version. Well, it's between 0 and 1, so we will multiply it by 256. The U size, and then we clamp the value, just to be sure, between 0 and 250. And return, and here we are. Select the entropy, zoom in a little. Already kind of feels better. And let's close this. Let's have a look. This is the old flame graph. And if I reload this as new, but take a look here, that color at index takes up a lot of time, and most of it is in preset spline. So let's reload this to the newest version. And we still have colored index, but now colored index is not calling out any other functions. We didn't measure total time or anything like that. And for that, we would need a benchmark that is more repeatable than my manual work. But you can see how this is very useful to identify hotspots in the program and then correct them. So, short recap. The Cargo Flamegraph framework is extremely helpful and does everything for us. We need to run it with sudo on macOS, but not on other platforms. This is the binocle tool with some, just a useful little binary visualization script. And then identifying where the time is spent and then just not doing it and caching it or whatever is appropriate. That depends on case to case, but often it's quite clear what the options are to improve it. And the first step is just to identify where our code is slow, which I think we've done here. Thank you very much. And if you have any questions, please don't hesitate to ask them.